EMG question of the day. How many fibers contribute to the amplitude of evolutional motor unit potential using a concentric needle with a recording area of 0.07 square millimeters? A. 4, B. 18, C. 10, D. 22. The illustration in this frame is that of a motor unit. A needle inserted in a muscle approaching the area occupied by a discharging motor unit will record a potential with a long rise time, as illustrated by the double-headed yellow arrow. As the needle gets closer to the area of the active motor unit, the rise time shortens, indicating the proximity of the recording area of the electrode to the muscle fibers or fiber, contributing to the amplitude of the potential, as illustrated here by the narrowing of the double-headed arrow. It is at this time that a motor unit potential parameters are assessed, and the contribution of the different muscle fibers to these parameters were investigated by different authors. Those authors investigating motor unit potentials brought about by minimal muscle contraction, as illustrated here, found that only some of the muscle fibers of an activated motor unit contribute to the potential being recorded. In this frame, I have encircled the fibers contributing to that potential. Here, I have projected the area of the circle by the broken lines and now added an eye to indicate the angle of vision. Now imagine that you are looking at the specimen from the perspective of the eye. Such perspective will produce an image as the one just added. This image shows the transverse surface of muscle fibers belonging to the activated motor unit. The muscle fibers occupying the light green area, corresponding to a 5 mm diameter circle centered in the recording surface of the electrode, determines the duration of the potential. Duration is a good index of the motor unit territory and is the parameter that best reflects the total number of muscle fibers within a motor unit. The area of the negative potential is determined by the muscle fibers within 4 mm diameter circular area, as you can see in this frame. Here, the area is colored sky blue. The muscle fibers within the cream color semicircular area with a radius of 1 mm from the recording surface dictate the waveform stability and number of turns, and the number of muscle fibers within the green semicircular area with a radius of 0.5 mm from the recording surface dictate the amplitude. The amplitude is the parameter most affected by shift in needle position. So the answer to the question how many muscle fibers from a single motor unit fits in a semicircular area within a 0.5 radius from the electrode surface would depend on the diameter of the muscle fibers, the density of the muscle fibers from the single activated motor unit in the territory closest to the recording surface of the needle, and the size of the recording surface of the needle. Kimura's book states, referring to a study conducted using concentric needles with recording surface of 0.07 square millimeters, that fewer than 5 muscle fibers laying within 500 micrometer of the electrode tip contributes to the high voltage spike. In fact, computer stimulation indicates that the proximity of the electrode to the closest muscle fiber determines the amplitude. So the answer to this question is A. Thank you very much for your attention.